Now, obviously, this won't work. You need to implement or import the correct classes. But once they're all there, it should work fine. But then what needs to happen here is, because we don't have a root node anymore here, we're going to need to create a root node, and that's going to be my application pane. And that's what we set as the root node for my scene, and then set the scene into the stage, and then so show the stage. So if I run this now, it's going to look a bit different because I forgot to do one thing. So I created my flow pane here, added everything to a flow pane, but I forgot to add it to my current instance, which is my stack pane, which is an application pane. So here I'm going to call this start at children, just like we added before, but I'm adding it directly to my container, which is going to be my stack pane, which I'm extending. And doing this, what we should see is we have the same window as we did before. Still has the label, still has the text field, still has the button where I click and it will say hello. Now, this is not what we want to do. We're going to try and create an actual application. So we're not going to get through all of it today. We're going to try and get as far as possible. What we will focus on is trying to do this menu bar. So having this menu bar at the top with different menu items, so different menus, and then different menu items in there. And we're going to try and do something that we can use inside of our specific program here. So we're going to take out all of these things. We don't need them anymore. We're going to do something a bit different, and we're going to use a different layout. And that layout is border pane. Now, with a border pane, if you remember, the border pane was something where we could have a top section, left, center, right, and bottom. And if you look at the methods that are available inside of border pane, we have set center, which takes in a node as a parameter. And then we also have top, which also takes a node as a parameter. So we're going to set our top and our center as soon as we create the necessary controls for that. So what do we want to have? We want to have this menu bar at the top, and in the center, we're just going to have a text field. For now, just a text field because we're not going to look at anything specific. In your next practical 4, which should be uploaded after I finish the practical lecture, there might be other additional controls you'll have to have a look at. You can look at the Java doc as to how those specific controls work. Some of them are going to be some things that we've seen before, text fields, labels, buttons. Some of them might not. So you have to read about how to actually use those specific controls. So for now, we're just going to do a menu bar. So let's start with the actual menu bar. And here, also make sure, just as before, we need to import the correct class. We want JavaFX menu bar, not Java AWT's menu bar. Okay, so that's going to be our menu bar. And let's just call this main menu bar. And that's going to be at the top location. So that's going to be the menu bar at the top. If we run this now, let me just check if we have everything. If we run this now, you're not going to see anything interesting because we haven't added anything to our menu bar. We haven't added anything to our center. Okay, so let me just move this code so you can actually see more at the time. So now what we need to do is we need to start adding things onto this menu bar. If you look at any application, we had a look at some of applications in the tutorial on Friday. You can see there is different menus. So each one of these are different menus. So you have file, edit, source, etc. And in each one of those, they have menu items. And each menu item, when you click on those, they will actually do the specific commands. So that's what we want to try and recreate. We want to try and recreate this system of menus with different menu items and menu items doing specific things. So let's create the first thing. Usually an application has a file menu where you can select files to either open or save or new. We're going to avoid new for now because we don't know how to create a new file just yet in our education system that we're developing. So we have a file to open. Let's create a file menu that will have an open, and we can open a file using that file menu. So here we need a menu, and again, make sure you import the correct one. We want JavaFX scene control. And here we're going to create the menu, and as I said before, it's going to be called file. And then what we want to do is we want to set or add that to our menu bar. So with our menu bar, we're going to use, instead of get children, you're going to use get menus, because that's how you work with menu bar. And then we're going to call add. I'm actually going to call, let's just call normal add for now. And that will add that file menu to our menu bar. And then with the menu bar, we already added to the top of our root. And that should be enough. So hopefully when we run this, window size did change again. Maybe we can fix that. But there you can see there is a file menu. So it looks similar to what we see here in Eclipse. If I click on it, nothing's going to happen. So I'm busy clicking on it now. We need to add some menu items for this to actually show something. So let's do the next step. So it's a good idea to add comments as you go. Okay, and what we're going to do here is we're going to add a menu item. And again, make sure you import the correct class here. And here we're going to have an item for opening. Again, it's going to ask us for a string as the name for the menu item. We're not going to do what it happens when you click on it just yet. So now we need to add to our file menu. Okay, let's try that again. And here I'm going to use add all, which is a method that can take in variadic parameters. So you can take in more than one menu item. And we're going to see why we're going to use that in just a moment. But for now, I'm just going to add one. So we created our menu bar, created our file menu, created our open menu item, put the menu item into our menu, and put the menu into our menu bar, set it at the top, and set it as part of our scene. So again, it adds it. If I click on this now, you can see we have now an open item. Obviously, if I click on this, nothing's going to happen because we haven't specified what happens when we click on the specific thing. So just as we did before with the button, we need to set on action. So set on action takes in an event listener, which takes in or has one single method called handle. We're going to use an anonymous inner class for this. And here we want to open our file. But for now, let's just print out a message. So again, I'm going to run. We should fix the size issue in just a moment. Then I can click on File. When I click on Open, you can see it does print out that specific message. We still need to actually open the file, but we've got a menu that can actually do a few things. And this one will eventually open a file. We might have other things besides just opening a file. We might have saving, we might have printing, we might have importing, we might have properties. Another one that might be interesting is exit. Yes. Okay, so the question was, when you click on the button, how does it know to run the proper code when it actually happens? So we actually answered this in the lecture on Friday. When we have an event, we have something called an event listener and an event source. The source is the button, and a listener is something that will listen for that event. Previously, before we added this set on action, it was creating the event, but no one was listening. Therefore, nothing happened. Set on action, if we actually go look at the implementation for this, it does get very convoluted very quickly. But one of the things it does is it basically adds this to the list of things that handle action events. So when this thing is clicked, this event handler is the thing that is notified that it needs to call that specific method. So we're telling the button, this is the thing that is waiting for your click event. When you are clicked, this is what you tell, and this is what needs to happen. So if you want buttons to share the code, you need to initialize them the same way. What we have here at the moment is set on action using an anonymous inner class instance, which means this button only handles this code. If you want this to be shared between multiple buttons, we can store this in a variable and then make the reference as part of set on action for multiple buttons. So the way we've written the code right now, one button has one action, but you can write it one button that can handle multiple actions, or multiple buttons have the same action. You can do those things, but for now, the way we're writing it is one button, one action. That will save us a little bit of trouble down the line where we need to debug what happens with the buttons. Okay, there's another question. Okay, so the question was about using an anonymous in the class. So I'm going to show you both ways, and that's what I'm going to do with the exit button. So I'll show you both ways. Both of them are doing exactly the same thing. Whether it's a Lambda or not, they're both handling an action event. The one just is less code to write. They still both create an anonymous in the class. They both implement that specific interface, and they both handle an action event. But one uses less code that you have to write out. There are some other things that happen with lambdas, but at the end of the day, for what we need to know for computer science 2A, it's less code to perform basically the same action. Okay, so let's go on to working with that exit item, which we talked about. So when you want to exit the application, usually you'll say something like file exit, or you might click the close button here. There is special syntax for handling the close button in the top corner. We're not going to look at that right now. What we'll do is add a menu item for exiting. So again, we need a menu item, and this one's going to be exit. And then we need to have this exit item have a set on action, and that on action will be when you click this, we need some action to actually happen. So I'm going to write this as a lambda. So here I'm just writing out what is the parameter for my lambda. That's going to be the same parameter as the single function here. And then the lambda syntax, which is that arrow. So this arrow will be the lambda syntax, and then whatever you put between these square brackets, that's going to be what's going to be inside of this handle method. So looking at the two on actions, this one is using an anonymous inner class, where we're creating an event handler that handles action events. It only implements one method because if we look at event handler, it only has one method. We'll talk about generics in a lecture coming up very soon. And this code here for the exit item set on action is exactly the same thing, except we're using lambdas instead of anonymous inner classes. It implements that specific handle method. It takes in a parameter of type event. You can see them both take in a parameter of type event and do something. And if I run the code, when you're running query applications, it's very easy to forget to close old running applications, so just be careful about that. So here, oops, I forgot to add it, so let's make sure we add. So here I'm just going to add, I'm going to add a separator, because if we look at these menus here, menu items are usually separated with a separator. So that's what I'm doing here. I'm adding a new separator. And then at the end here, I'll have my exit item. And if I run, what I should see is my two menu items. And you can see there's a separator between the two. And if I click on this, you can see it does print out the message we need to do to exit application. Now let's not print out the message. Let's actually do exit. If you're in a console application, you would do something like system exit. And then if you remember things that you did in C++, you exit with a specific status code. If you say 0, 0 means everything ran fine. Negative numbers mean something, positive numbers mean something, but usually something didn't go fine if it's not 0. That's for console applications. For JavaFX applications, we actually have to use a different class called platform, and then call exit on that specific thing. And this is a static method from platform, and this will cause a JavaFX application to terminate. So this is the right way to exit out of a JavaFX application. So if we run now, and I click on File and I click on Exit, it will close my window. Let's solve this problem of the size, because the size doesn't look that great. So here we can set the preferred size. The preferred size is the size that this control wants to be. In this case, our control is our application pane, and we can just give a number like 800 by 600. And there the window will always come at that size. You can change, obviously, you can change the size to be a bit bigger, a bit smaller if you want to. And obviously it will appear at that specific size. Now there is a way to try and say that you should make it adaptable to the platform you're running, because this, at the moment, I'm working on a laptop with 1080 resolution. I should open up a window that should be smaller than 1080. Obviously, I wouldn't be opening up an application that will be bigger than 1080, then it wouldn't fit on the screen. However, some systems might be opening up on smaller resolutions, might be 720, it might be 360, it might be very small. So you need to take into account when you open up these windows what size they should be. For our purposes, anything that's less than the screen resolution is perfectly fine. There is another way that you can open up to be maximized, fill up the whole screen. We'll have a look at that at a later point as well. Okay, so we got to the point where we now have our window, we have our menu, and we have exit, and we have open, but the open doesn't actually open a file. We have a way to process the information in a file. There's a file handler here, but now we need a way to actually open the file and make that file available to our application. So here in the example section at the end of the GUI lecture, there is menu bar with menu items, and there's also something called a file chooser. So a file chooser will allow us to provide a dialog to the user. That dialog is something that will pop up on the window and show to the user saying that this is asking the user for something. In our case, specifically for opening, but we'll see there's more ways you can use this dialog as we work with GUI interfaces. So it's a good idea that we don't create the file chooser inside of the handle, because we want to reuse the same file chooser over and over. So usually we create this as a local variable. You can put this as an instance member if you want to, if there's a reason to, but most of the time having it as a local variable is perfectly fine. So that's creating the file chooser. Now, one important thing that you should always do is when we look at a file chooser, you need to specify the initial directory where that file chooser will work. We have, for every application, a data folder, and that's where all the files usually belong. So we're going to specify for our file chooser what is going to be the initial directory. It's going to be data. So that will create a file handle that will point to that data folder, and when we click open, it will point to that data folder. If you leave this line out, it will go to the user's home directory. On a Windows, that's in Documents, My Documents, the folder. On Unix systems, that is your home directory. So we don't want to open up in the home directory, because then you need to navigate to where your project is. It might be on a different drive, it might be in a different location. So the best way to solve that problem is by default open up on the data directory. That will make sure that you're in the right folder whenever you click open with the file chooser. So let's actually open a file here. So we're going to say file chooser, and we're going to show, and if you look here, there's actually a few methods available. Show open dialog, show open multiple dialog, and show save dialog. So each one of these things do something different. Open dialog will open a single file. Open multiple dialog will have multiple files. So it's not just one file, it will have multiple files that can be opened. And you can see there, it does return a list of files, and a list is a generic class, which we'll have a look at when we get to working with generics. And then the last one here is a save dialog, which also returns a file. So for now, we're just going to focus on open dialog. And with the open dialog, you can see there it specifies a parameter of owner window. For now, we're going to leave this as null. We'll see what we can put there to make this work correctly a bit later. What we're more interested in is the file that it returns. If the user selects the file, it returns the file the user selected, or null if no file has been selected. So very important, if we get back null, it means that the user hasn't chosen the file. And we can confirm this by running code and checking those specific things. So now, for now, owner window is going to be null. So let's just put this as null. And we're going to get a backup parameter of type file. And for now, let's just put that information on the command line. Again, we're going to run file open. Now, when I click on this, it's going to show me the file dialog. There you can see the open file dialog. And there's multiple things the user can do. The user can choose a file, click open. They can choose a file, click cancel, or they can choose no file and click on close. If they click close, what we should see is null. Let's just make this a bit more user friendly. So close this, let's zoom back out. Okay, so I'm just putting out some extra text there to make it a bit more user-friendly when we read our error messages. So I'm going to choose open and I'm going to click close here in the top corner. And you can see there the chosen file is null. I'm going to try again. Instead of clicking on anything, I'm going to click here cancel. Don't worry about that. That's something else. If I click on cancel, you should see that it says no. And then the last one, if I click on a file and I click open, you can see it does provide a file handle that is valid. So that gives us a way to open up a specific file. Now this just gives us a file handle that's valid. It doesn't mean the file exists. Remember, we can check that with the exists method in the file handle, but now we can actually do something with that information. For example, if we have an indication of chosen file being null, we can just put out an error message, or maybe in a live application, we can put that into a log file. And maybe you want to say at this point here, we return because we can't do anything after this point. If the chosen file is not null, then we can process that specific file. We have a education file handler, and we have something that can read a file. So we can process that using our file handler and then do whatever we need to. At the moment, we don't have anywhere else to display the information, so we'll just put it in system out. So if I run this again, if I open and I don't choose a file, no error messages, because we said if there's no file chosen, we're not going to try and open the file. We'll just print a message onto the error stream. However, if I click a file and I click on the file that is actually valid, you can see it does process the file. This is the output we're getting for reading the file. It tells us when there's a student being found, etc. We can go check that inside of here. So if there's a problem, header does not match. Otherwise, it will say something like found a student or found a lecturer or no match. And indeed, that's what we see inside of our console here. Found student, found lecturer, etc. And then right at the bottom, we didn't override the toString of degree. That's why we have the usual thing of canonical name at hashcode. But let's see if we can actually put this information somewhere where we can actually see. So we handled top, which is our menu bar. So I'm just closing the old runs of our system just to make sure they're all out of the running application. And what I want to do is I want to set the center to be something. So let's put a new control there that we can set. So let's have a text area. Again, make sure you import in the correct text area class. Now, when we do more complex GUI interfaces or more interesting GUI interfaces, you won't just dump everything into a text area. You'll have a label and a text field for each of the relevant things. So for a degree, what's relevant in a degree? You might have a label and a text field for name, a label and a text field for code, duration. Students and modules, we can't use labels and text fields because there's an array of them, so we'll have to use something else to display that information. But you would have to write a custom thing instead of just dumping everything as text. But for our purposes, just for demonstration, that's what we'll have to do. Otherwise, this tutorial will go on for a very long time. So here, I'm going to have a text area. And I'm actually going to put this text area declaration up here at the top. And the reason why I want it at the top is because I want to reference that text area inside of our handlers. So with our handlers, we want to say that for a specific thing, we want to display some information. So let's just do the same thing here. So here, because I want to format the string in more than one place, or use that formatted string in more than one place, I'm using it like this. So that will print out to the system out as well as this text field that we have. So when we run, let's just do the degree as well. And here it's complaining that it's getting the degree, but it's expecting text. So we have to manually call toString in that case. If we run now, open, choose the correct file, what we should get is not the right output because I forgot to set the center. So let's just do that. So now you can see there's a text area. You can see there's a blue outline here showing the text area. And now if I open the file and select, what we should see is there's some information and there's the toString of the degree. If you want some more interesting things, we could change this to, instead of printing out the degree like this. Okay, so it's complaining I didn't import the right thing. So let's just make sure we import module. That should work. And if I run it, open the degree file, we should get some error message. So here's something wrong in our code. What do? We don't give up and ask the lecturer. You first read your message. So it says there is a null pointer exception because M is null. So it's saying us M is null somewhere in our code. Now you might see there's a whole bunch of other things here. You should only look at the things that you wrote. So here, CSC02A2 UI application pane. There's some funny thing here. $1 dot handle. This $1, that's actually the name of the anonymous in a class. Even though we don't give them a name inside of code, when you compile, they need a name. So usually it goes $, and then 1 or 2 or 3, depending on how many anonymous classes you have. And it will tell us what line that is actually the problem. And there you can see it says here M is null at this point in time. So we can just do a check here. Okay, and if we run that, open the right file, and then because I forgot to put new line characters, it's printing out each module on there. If we overrode 2 strings, then we will be able to see the information about the things inside of there in a different format. That's if we choose the right file. Let's choose a wrong file. I haven't written code to handle incorrect files. We handle cases where the user doesn't choose a file. If we choose another file, so let's choose this dates.time file. Remember, dates.time had the dates to test our regular expressions. Obviously, this is not something that can handle degrees with modules. If I click open here, this still displays that we chose a specific file, but then our code doesn't work. And the reason for that is we haven't handled the situation where the file handler we have, education file handler, if something goes wrong, it returns null. So if we get back a null here, that means it wasn't read correctly, which means we need to add some code here after this point here to check if the degree is null. If it's not null, we can process it. If it is null, we can display the message to the user. The file you have chosen does not have a valid degree, something along those lines. Okay, so I'm not going to write the code for that. That's an exercise for you to do. The last thing we want to have a look at is looking at shortcut keys. So there's two versions of shortcut keys. One is called mnemonics, and the one is called, or accelerators mnemonics, and then the other one is the alt codes. So if in any application you hold on the alt key, so obviously you can't see what key I'm pressing, but I'm pressing the alt key, and if I do that, what you'll see is in the menu here, certain characters are underlined. So there for file, the F is underlined, E for edit, S for source, the T in refactor, N for navigate, so on and so forth. And if I press F, you'll see the menu for file now open up. And if I press the next thing, so the next thing here would be N for new, then it will carry on. So this is a way to have shortcuts in. So that's the Alt shortcuts, but there's also accelerators. So if you see here, there's Alt Shift N. If I press Alt Shift N, I get exactly the same window or menu that I had here. So it gave me this exact same thing by pressing that shortcut. We can put some of the shortcuts into our application as well. If you want the application to show alt codes, all we have to do is when we name the menu or menu item, just put an underscore before the character we want to have underlined in our shortcut. So for a file, we'll have F. For open, we'll have O. And for exit, we'll have X. So if I run this application again, so I'm going to zoom in again. If we have Alt being pressed, you can see now it shows F. If I press F, it will show me O and E, sorry, X. If I press O, it shows my open dialog. And again, if I press Alt F, oops, so we will have a little bit of a problem if you have a text field that's highlighted, but usually if you click out of the text field, you can get away with it. So now I'm pressing Alt F, and then I'll press X, and that will exit my application. So this is for users who know shortcut keys. This will be very nice for them to use. So let's add an accelerator for opening. And here what we want to have a key combination where we specify a key combination by string. And you'll have to read the documentation about how to do this. But what we're basically saying is we need to press the shortcut key and O. Now the shortcut key depends on which operating system you're working on. On Windows and Unix, it's the control key. On Mac, it's the option key. So Mac doesn't have a control key, it has another key called option. But if I do this, and now with my program selected and I press Control O, I get the open dialog. So it's very easy for someone to then use my application because they can use certain key combinations. Just like if you're using Eclipse and you need to save, what do you press? You usually press Control S or Control Shift S. What does that correspond to? Save and save all. So you can have these key combinations in your application as well to perform certain tasks. And if we look at the application itself, it tells us that key combination as well. So you can put these extra key combinations into your program. I would suggest doing that after you have the program actually working, not before. Other things you might want to do is, instead of exiting outright here, you might want to ask the user, are you sure you want to exit? They might have unsafe files. They might have another reason why you want to check that, are you sure you want to quit? So that's other things you could add in any GUI application, not necessarily just the examples we go through or the practicals. Any GUI application, it's usually a good idea to ask the user when they want to do something that might be destructive, such as closing the application. All right, so I think that's where I'm going to stop right now. So we covered sort of the end here, looking at the file chooser, menu, bar menu, and menu items. We're going to get to working with the low-level rendering and the canvas. So we'll have a look at that in the tutorial tomorrow. Okay, so I'm going to end the lecture there. Let me just check Blackboard for any questions. All right, so one of the things, okay, so I'm not going to end the lecture there. Just give me a second. All right, so just to recap what I covered on Friday, yes, I didn't record the first part, but I went through everything you need to do to add JavaFX into Eclipse. So just to recap that, you go to build path, add library, user library, and then the way to do that is in the previous tutorial. I'm not going to go through it again. You can watch the previous tutorial on Blackboard for that. The other question was, how do I get this to show JDK 17? Now, if you're using the machines inside of the computer labs on campus, this should automatically be done. If you are doing it on your own system, this might not be correct. In which case, what you need to do is then go to Preferences, Java, install JREs, and here you need to click on Search and choose the folder that has the JDK inside of it. So this is actually the C drive. Don't click on the JDK, because if you select it like that there, it's not going to find anything. You have to choose the folder that has JDK 17 inside of it. If I click here and I select this folder, it's going to scan everything in this directory, which is going to take a long time, but eventually it will get to that location. To give you an idea of what it should look like, I'm just going to choose something else. Here you can see I do have different other JDKs installed in this folder. Hopefully this will take less time to scan. There you can see it's already found other JDKs. I'm going to stop it there, but it should come up with whichever version you have. So here we are using 17. That's why I'm leaving it as 17, but that's how you can add JDK 17. If after you click that checkbox that says this is the right version, your JRE is not correct here, change it, right-click Properties, use Workspace Default, or you can specify use an alternate execution environment, and then just go look for Java SE17, and that should work perfectly fine. So I'm not going to go through adding the user library. We did that on Friday, and yes, that's the full lecture covered there, even though I did forget to record the first part. The first part was me making a statement about students being in class, and you should be in class, but everything was recorded for that. How can you get the batch file for JavaFX? We talked about this on Friday as well. It's already on Eve. It's already there that you worked with it previously. It's the same batch file as usual, except that you need to go change one thing inside the batch file, and that is, okay, to change that JavaFX to be true instead of false, and then everything should work. Okay, so I'm going to stop the recording there.